Scott.
So let's go over oxidation of alcohol to synthesize carboxylic acid. So this has to come from a primary alcohol. So this is 118A review here. If we have something like this, and we put it through Jones reagent, which could be in the form of CrO2, H2SO4, water, or CR2O7, same thing. Or you can just see Jones. This will fully oxidize this primary alcohol into carboxylic acid here. Okay. There are other ways to form carboxylic acids as well. Like you could also start from an aldehyde instead of a primary alcohol. This aldehyde can go make Jones, go make carboxylic acid by using Jones too. Another way to create this carboxylic acid from the aldehyde is the Baeyer-Villiger reaction from 18B. MCPBA or some kind of peroxy acid or CO3H. Right? Where if you have a carbonyl here, this hydrogen is the highest priority in the migratory altitude. That's why the oxygen will insert itself between that carbon and the hydrogen there to create that carboxylic acid. Okay. Okay. So let me just look at the study list to make sure everything is in here. Okay, this is it.
Okay, let's keep going.
Okay. So there are two ways to make carboxylic acid with an extra carbon. One is
Wait, can we guess?
yeah. What are the two ways?
Hydrolyzing a nitrile, and then is that one of them?
Yeah, that's one of them.
And then the other way was MGBR attacking a CO2.
Yeah, those are the two ways. Where the first way, hydrolysis.
You probably forgot.
Nice, sorry, the other way is going to be
So instead of looking for what happens when you add Li4 to amines, I looked at
followed by
oxides, right? Because both of them were oxides. So we didn't have this, I don't think, but you can open oxides with reducing.
let's say we have
Because if you think about it, all we're doing is reducing
two
H,
carbon
so
chains
adding
here.
a hydrogen, right? So if we add a hydrogen, we're breaking one of the bonds.
we can do
oxide, we're
NaCN
opening.
for SN2 reaction to substitute that bromine
So
to the
as to
nitrile here.
whether it's going to be,
We could then
well, actually, can you
hydrolyze
like
this nitrile into a carboxylic
Okay,
acid.
yeah. So I believe the answer, right, was
Using
that it opens
H2SO4, water,
secondary,
and heat.
right? So it doesn't matter which way you open it. So in my mind,
That
it makes sense that
gives
it
it
should
an
be
extra carbon from the reactive molecule here. So if you see an extra carbon in the product, you know that in synthesis, you're either going to do hydrolysis of nitrile or
Yeah.
figure it out and ferment it.
Yeah, I don't think so. But just in case you're curious, just
So,
know that if it's epoxide,
For the
it can be
gradient one,
opened by
let's say we
anything.
have that BR here.
Attack at a position,
We can make that into
or
a
go
gradient
into the
by
hydrogen
putting in G,
to get it to, its reduced state and open one of those bonds.
which is going to create a
I
negative
wouldn't
charge
worry
on
about
that
it.
carbon
I've
right
never
there.
seen that before.
And then
And
we
it was pretty hard to
react this
find.
with carbon dioxide, CO2, which is like this. Okay.
Yeah, of course. Anything else?
We know this carbonyl carbon is positively
Just sit and
charged
enjoy
to get
the-
attacked by the
Yeah,
negative
yeah,
charged
yeah.
carbon.
Yeah. Well,
Pop
just
the
let
double
me
bond in there.
just enjoy the
Star,
breath.
dot, double bond O there, O minus, and then the H plus workup will just neutralize the O minus into the carboxylic acid here. So both of these ways will create an extra carbon, but there are limitations for both. Since we are in acidic conditions here, right? This would be this would also react with alkenes
should start? It's like
it's like
5 minutes.
And then this right here is a strong base.
So it attack under OH.
Yeah, that can
Go over like any crazy notes.
deprotonate
Chapter 17. Right?
Yeah.
I came when he just started Jeopardy.
intramolecular OH.
Can it deprotonate anything else?
Yeah, it could also deprotonate an amine as well. NH2. Any hydrogen that is bonded to an electronegative atom. So I'll give you an example of both. Like, let's say we have
So we have a copy that.
Yeah.
the synthesis here, where we created an extra carbon and a carboxylic acid. Or both. Which route do you want to use for the first synthesis here? Hydrolysis of nitrile or Grignard? Yes, Grignard because
There's an alkene.
alkene, right? If we did NaCN here, this would become a CN. If we wanted to hydrolyze that nitrile into the carboxylic acid, the acid here would also, in water, would also react with the alkene. This is 118B material, like from the alkene chapter, where it's like the Markovnikov position, but in this case, there's no like Markovnikov position, where alcohol is going to be either here or here. This is 118B. 118B. Right. So what we're going to do is Mg, CO2, this whole step here, which will create that extra carbon, carboxylic acid thing. This one, we gotta use the hydrolysis of nitrile. Because if we try to put Mg here, this negative charged carbon is really basic. It's not gonna attack a carbon dioxide, it's gonna deprotonate the alcohol hydrogen instead. Because the acid-base reactions are one of the fastest reactions in OChem, like alongside with intramolecular reactions, right?
If you had a carbonyl on the molecule, could they be doing like some intramolecular if it was an MGP?
Yeah. If there was a carbonyl instead, then it could do an intramolecular reaction to form a ring. But in this case, it can't do it because that carbonyl would be is too
ring
ring strained, right? But that's in that case, it won't do it. But if it was farther down the line,
It could do it.
it could do it.
Got it.
Yeah.
Is that
Oh, this is very similar concept. Where we do have a Grignard right here, which is a strong base. So it's gonna do an acid-base reaction first before a nucleophilic attack. So if you have an acidic hydrogen somewhere, it will deprotonate the hydrogen first before attacking the carbon hydrogen. Right. So that question is really tricky.
is that the no reaction one?
That's the no reaction one.
No reaction, or
And
it
also
actually
it's
does.
carboxylic. So carboxylic always happens in acidic, no?
No
Not
reaction.
necessarily.
I think he also accepted this as the answer too.
Or you might go.
Right, which is the more accurate answer.
If you
Because
take a photo
the strong
with the
base
flower,
will deprotonate the
Because
carbon
it's like
acid.
resonance
put it in the
stabilized too,
newspaper,
right?
Yeah.
you get a husband.
Electronegative.
Yeah.
Also
Like I
like
was
that.
posing right for photos, and he told me, he like yelled, if you take
Okay,
a
I
photo
see you,
next to a
Brian.
flower, you'll be next. And I was like, okay.
Go deprotonate.
Yeah, it will deprotonate first before attacking the carbon.
You did this in 118B too for the first midterm. Wait, can I ask you about Dibol?
Dibol, yes.
What the hell is that?
Okay, we can do Dibol really quickly here.
Yeah.
It's really, like, once you know it, then...
I completely forgot about it.
What is Dibol?
Can I take a picture?
Yeah.
I just remember like it was some way to like do something with a nitrile without hydrolyze, without a strong acid.
Okay, why is this not?
When I go over Dibol, I'm going to go over the...
Beautiful, go. Thank you. Thank you.
Grignard and then the bulky one.
You're taking a photo? Yeah, exactly. Like, what is this?
Thanks, girl.
Typical Jackson.
Yeah, I need my picture.
Okay, let's go over Dibol.
You okay? No rush.
This one with Helix. This is Helix and Whitney doing partying together. This is my old
with diamond. Diamond is a reducing agent.
Your mom's gonna.
And here is the important thing to know about it. It will really reduce three things. Ester, amide, or nitrile reacting with diol will always give you an aldehyde.
Okay.
So that's all you need to know about it for this thing. Right? So examples, something like this. The tricky one here is probably the nitrile. Where you react all of these with diol.
Okay, that's probably their problem then. Because I didn't use a lot of sprays too.
Oh, like for the first midterm, that's what people did, right? They formed a nitrile and then did diol.
Yeah.
That was it.
Great, to get the aldehyde. So
You remember?
always find the carbonyl-carbon of either the ester or the amide here. That is the carbon that is the carbonyl-carbon of the aldehyde as well. The tricky thing here is the nitrile because there's no carbonyl-carbon for nitrile. Look for the carbon of the nitrile. That's the carbon that will become the aldehyde, right? A lot of people they list that carbon right there and they put the aldehyde on that carbon attached to the nitrile, right? So for ester, the answer would be this here. Where that carbon becomes aldehyde, this becomes this aldehyde, and then this right here, the nitrile, would become this aldehyde here. Where that carbonyl-carbon is that carbon of the nitrile, right there. It is not this right here. Not that. Because this carbon here is not the carbon of the nitrile. So, do not put this. No.
Let me figure it.
This is missing a carbon.
Oh yeah, we went to the
It disappears.
Why?
No, because I don't know
You
what's
wanna
gonna
really
jump at you or
No, but like, but how does that whole thing, you know, goes bye-bye? Oh, it's
She wrote it, I'll just say bye.
and then that's the message.
Yeah, right. So you can just think of it like this.
Yeah.
The OR group of the ester becomes the H of the aldehyde. The amine group of the amide becomes the H of the
I know I'm
aldehyde.
screaming and Becca's like,
So the metal is like a different type. Oh my god, what if there was an ether on, or ester on the other side?
Ester on the other side, this side,
Yeah.
then what you will
Choke is
get
fly.
is
I know, I'm like,
formaldehyde.
oh my god.
Formaldehyde.
I
Oh wait,
didn't know
that's not even an ester.
Wait,
Oh
what?
yeah, yeah, it is.
You would have formed what?
If it was like another ester and amide, it would reduce both ester and amide into aldehyde.
You know, that was a
This
good
is
question.
Formaldehyde.
Because that's the question he would ask, and he would be like, oh, I don't know if I should do both.
Tricky. Good question.
Okay. Are there any like exceptions? Is diamond like basic? Because for some reason I remember
Yeah,
writing
I think it was basic.
Oh my god.
Basic, yeah.
Does that mean anything? Like, should I be worried about rotating shit? Now,
If he gives a carboxylic acid, then it would go into the carboxylate.
oh my god.
Or you can just write no reaction, because this would not react with carboxylic acid. Like he accepts both, no reaction or the carboxylate. It's like the Grignard. Yeah. Like
So instead of like an S there, it was an OH.
OH, yeah. No reaction or the carboxylate. Right. Uh-huh.
Like, why would they no reaction?
It would just deprotonate it.
Oh.
Yeah, it would just deprotonate it, because this is basic. They give it like a Grignard reagent. Acid-base reactions are faster than like any other reaction, like reduction, oxidation, nucleophilic attack, electrophilic attack, something like that. It's gonna do acid-base reaction first, deprotonating the carboxylic acid.
But is diol strong base?
Yeah. I don't think that's strong.
I should write it down.
Yeah, it's good.
Okay.
I think it's basic.
Not as strong as Grignard though.
So Grignard's on top.
Yeah, your Grignard's on top. And the stronger one than that is organolithium, the RLI, the individual lithium, which is like Tyson's.
Oh yeah.
Oh, not the thiacetal. Thiacetal.
Yeah.
Like this little thing here.
Yeah, that's what I mean. Yeah.
The little tail.
Yeah.
Why are you calling it?
That makes sense.
Okay.
It's like the sound.
So this is reduction with diball. Let's go over reduction with the really bulky one now. Before we go over that concept, let's go over the different derivatives like acyl halide, anhydride, ester, amide, nitrile.
All I know is like the tip is always make it an acyl halide, right?
What always makes it acyl halide?
No, like try to go to an acyl halide before going to anything.
Yeah. Before trying to go to make any other derivative.
Double bond OCl.
No. Because I probably look like a rat.
Yeah.
What's the acyl is the double bond?
Yeah, acyl is a carbonyl.
Halide is the
The
Cl.
answer key for these?
I haven't made it yet, but I can send it to you. If you try it, I'll send it to you.
I haven't done the practice yet.
Oh, practice this yet for the final? Yeah, no.
Some of the tutors ones, right? But at least for 118, most of us are studying.
I'll send you
Well, you can go on this, right?
and I'll also like.
I could hypothetically go on.
17, 18.
You could do.
There's a more. Oh, wait. Why do you
So,
Because I can't find like the right one.
carboxylic acid is the
Sometimes
parent chain.
Becca is not the
I
vibe,
agree.
okay?
So,
um,
do you guys remember the?
then I see my face and
top two
then
most-
I look like
You
a
go
rat.
acyl halide. Double bond OCl and
Going from
Oh yeah.
one
the
photo
acyl
like to one
halide.
photo, Becca.
Yeah, no shit.
Yeah.
Going to be that one.
Oh, wow.
I know, I archived it. Because this is only for like 5 days of attention.
That ranking it shows which one is the most reactive.
Okay, stop checking your
Everyone
Apple
Most
Watch.
wanted to
reactive,
see it,
yeah.
so
And there's two factors that go into
Nobody
that,
messaged
the leaving
Jack.
group ability and the carbonyl carbon.
Yeah,
electric
emails.
ability.
Probably emails. Oh my god.
Like
Like a LinkedIn notification.
like how positive
Instagram probably some
the
like
carbonyl
random
carbon
person.
is. Like if it's more positive charge on the carbonyl,
You don't-
it's more reactive.
Yeah.
Tape is crazy.
I'm putting it on public.
So it's like this one, and then
Do not follow.
Then it's the most reactive
Jacqueline.
because this is the most electronegative.
You guys follow any Jacqueline.
What time is it?
It's bad for your health.
I have a train to catch at
For acidity, that could be a different kind of ranking. So that's it. Yeah. The reactivity, like, yeah. Go for it. No, it's okay, it's okay.
so that
So-
me and Becca can sit and study together.
The next one is gonna be.
Becca, my cat.
So, a lot of questions. Why is the anhydride very a good leaving group because it can do resonance once a week?
Yeah.
Okay.
That's right.
You gotta understand the why.
Yeah, I gotta understand why.
I said anhydride's a good leaving group because it can do resonance once a week.
Tries to bait me.
Yeah, that's the whole thing that's leaving. Wait, where this is the most reactive derivative,
I
this is the
bait
least reactive
her.
derivative. So let me put that chart down like this. So the most reactive is the acyl halide.
No, I believe the cats need to do that.
The least reactive is the nitrile, and there's two factors: leaving group ability
Yeah, Becca's upstairs.
and
Electronegativity.
electrophilicity.
Shit. Oh, like how electrophilic it is?
Carbonyl carbon.
I agree.
So it relates to the electronegativity thing that you talked about.
Yeah.
Because the more electronegative the atom is, the more electrophilic the carbonyl carbon is.
Pretty much. Yeah.
But this is the main reason why.
Okay.
But it's interconnected.
It's okay. I get it.
Yeah. Okay.
You don't have to feel bad.
Okay. Let me.
Why do all the companies and it's like
Where did? Okay. Here we go.
it's almost like
Where's the red one?
it gives cuter energy.
So I'm gonna circle
The photo I
the
sent
leaving group in
earlier
blue.
today.
That's the leaving group for the acyl halide. This is the leaving group for the anhydride. Leaving group for the carboxylic acid. Leaving group for the ester. Leaving group for the amide. Okay. So let's make the line here. This is a cousin. The cousin of the family.
Wait, what cousin?
This is a cousin of the carboxylic acid derivative family. Because there's
Why
no
is it even?
carbonyl.
Why is it even there?
This is this.
Because this can get converted to a
Oh, it could.
amide.
Got it. Got it.
By hydrolysis, and then this amide can then get converted to carboxylic acid.
I see. I see.
So wait, I'll get over that later.
Cousin.
We'll get most of the reactions in this track here. So now, if you imagine the leaving is leaving, the X minus is the one that can hold the negative charge the best because it's the most electronegative. This oxygen minus here is relatively stable because of
Resonance.
resonance. It gives you resonance with the carbonyl right there in the leaving group. This OH minus here is a better leaving group than this OR minus.
Is there a reason for why?
Yeah, it's because R groups are
Electron donating.
groups. Donates electrons,
You're lucky.
electron repulsion. Hydrogens are not electron donating. Right. Yeah. So hydroxide ion negative charge is a better leaving group than the alkoxide leaving group negative charge because this negative charge is more stable since the hydrogen here is not EDG. It will not donate electrons and make this less stable. But this R group here is an EDG, which will donate electrons and make it less stable because of electron repulsion. Like electrons don't want to be near each other.
You see.
The amine here with the negative charge is the least stable because the nitrogen is the least electronegative out of halogen and oxygen. Right? The negative charge prefers to be the oxygen over the nitrogen because oxygen is more electronegative. So that's the leaving group ability factor of why this is the most reactive, this is the least reactive. But we'll worry about the nitrile later. The nitrile is a cousin. Now let's talk about the electrophilicity of the carbon to carbon.
So in which case it's the highest?
Yeah, in which case it has the biggest partial positive charge.
I want to say in the first one.
Yeah.
Because you have a halogen, which is super electronegative.
Right. This carbon to carbon here has the biggest partial positive charge because it has the super electronegative halogen there.
This one you have two oxygens, so that's pretty electronegative.
Right.
Now, I'm wondering why would the OH be more electronegative than the OR? Wouldn't the OR be more electronegative? You also have like.
Right. So, let me
Ask me the question.
This is the more important factor than this electrophilicity thing because the partial charges of this carbon and carbon is relatively the same because they're attached to the same atom, oxygen.
I agree.
Oxygen, oxygen. So that's why the electrophilicity is a smaller factor than the leaving group ability. The more important factor is how the leaving group leaves with the negative charge. If it's more stable, it's a better leaving group.
I agree.
Wait, the nitrogen here has the smallest partial positive charge because nitrogen is not as electronegative as oxygen. Which is why this carbon has the smallest partial positive charge.
Chem concepts.
Yeah, Gen Chem. And also OChem, like 118A.
Gen Chem.
Yeah. Okay, so that's the two factors that determine the reactivity of these derivatives here. Now let's go over the reactions.
You don't need to perform them. It's okay.
All of these carboxylic acid derivatives here can create this parent function here, the carboxylic acid. And what reaction do you guys remember that can do that?
H2, so would it be H2SO4 or H2O?
Yeah.
Actually, for nitrogens, you can't do that, right? You can't use an acid for nitrogen.
Oh, for
Amides.
amides, you can't use acid.
Oh no.
Oh, no, you can't use base. You can't use base.
Yeah, I think you can do that.
You can do acid, but you can't do base.
So you do H2SO4, H2O,
H2SO for H2O for the top two most reactive
and
ones.
then do you need heat
For
for
these
this?
less reactive ones.
Got it.
So let me separate this into different lines. These two are the goats. These two are the most reactive, which means that they do not need heat and acid or base. So this two here just need water to get to carboxylic acid. They don't even need H2SO4.
Oh really?
Yeah,
Okay, wow.
yeah, they don't need acid. Here, this water is enough to make these two go back to the carboxylic acid. These here are the less reactive ones. They require heat and acid or base catalyst, except the amide. Wait. The amide can only work with acid. Wait. Amide,
Which only works.
only acid. No base.
I agree.
The reason why is because think of the hydrogen here of the nitrogen as really acidic. If you put a base, it wouldn't attack the carbon and carbon. It would do an acid-base reaction instead.
Why is that one? Is it? But isn't that OH also very acidic?
This OH here,
Yeah.
it is, but not as much as. Wait, hold on.
No shot.
Oh wait, it is very acidic. Right. It will get deprotonated into a carboxylate if we put a base in it. Because this is already the carboxylic acid here. If we try to put a base on it, like a Grignard or Diebol or any base,
Wait, I'm stupid. We're trying to form a carboxyl.
yeah, we're trying to form a carboxylic acid. And then if you put a
Okay.
base on it, then this could turn into carboxylate.
Get humble.
Similar concept as over here. The amide nitrogen here will get deprotonated, which is why it doesn't work in basic conditions. Like, I just realized that now. I didn't know like why.
So
until now.
I made you realize.
Yeah, like I'm learning things like every day. new perspectives, new insights.
Damn, that's inspirational.
Yeah. Like I always knew like the amides only work in acidic conditions, but not basic conditions. And the reason why is because this basic condition here would deprotonate the hydrogen here. It would do an acid-base reaction instead. It would work. Like
Why
this.
is
Would
no
work
point?
if
Why do you not get?
you have this instead.
Well, if you did that, then
Yeah. Then the basic conditions could work with this tertiary amide. Because there's no hydrogen on that nitrogen right there. So that could be like some kind of conceptual, tricky explanation question.
Why do we put drinks in the sink?
Okay.
Okay. So for hydrolysis, I'm gonna do this in green.
Would you drink
I like the color scheme.
from this to the sink?
Hydrolysis
Would you ever drink
would
from
convert any of these derivatives back into the carboxylic acid.
No, like
and this
this.
showed up again in the Kaizen chapter. Because you know how there were esters everywhere? Whenever you had H2SO4 with water, it converts it to carboxylic acid, and then the new thing was decarboxylation, which gets rid of that. But this is from the Midterm material. Converting the ester to carboxylic acid is the H2SO4 water and heat. That's from the Midterm 1 thing. These two here, we said to do that, we just need water. Water. No acid needed, no base needed, no heat needed. We put all of these here. We're gonna need acid, water, and heat. Because these are not as reactive. That's hydrolysis. That's the reaction there. Okay, so the next thing is So the next thing,
Is this like all midterm one?
yeah, this is on midterm one material. Right. The more reactive derivatives can make any of the lower reactive derivatives in one step. Right. So this acyl chloride can make anhydride in one step. It can make a carboxylic acid in one step. It can make an ester in one step. It can make an amide in one step.
Damn.
Anhydride can make this in one step, can make this in one step, can make this in one step, but it cannot make this acyl chloride in one step because acyl anhydride or anhydride is less reactive than the acyl chloride, so it can make it in one step. Only the high reactive things can make anything lower than it in one step. Okay. So to make this acyl chloride into the anhydride, what you're gonna do is look at the leading group of that anhydride, draw that out, and put a hydrogen there. This is a carboxylic acid, which if it reacts with an acyl chloride, would make an anhydride. Same as for this carboxylic acid here. Look at that leading group, OH, put a hydrogen there, H2O. Now let's look at the ester. Look at the leading group, RO, to create the ester. RO alcohol. Alcohol reacting with acyl chloride, ester. To create this amide, look at the leaving group, NH2. Add an extra hydrogen there. NH3. Now this is a little tricky one to create the amide because you need at least 2 equivalents. From the acyl chloride to the amide. You need at least 2 equivalents.
And why is that?
Because when we do the whole mechanism, the nitrogen here will have a positive charge, right? Which at the last step, you gotta deprotonate it. And the deprotonating base is another version of the amine here. Okay. We don't want to use X minus because that's gonna give an toxic like gas in the lab. In paper it doesn't matter, but in lab it does matter.
Okay.
Yeah, but Helix does also put 2 EQ on this lecture as well. But if you put excess, then you'll be safe. Excess.
Yeah, I look
Excess, yeah.
I'm gonna take a photo. No,
Not yet. This is the thing. Okay. So, wait, yeah, you guys can do this now, but this is just an explanation thing. Let's say you wanted to create another thing. If you wanted to create an acyl
SOCO2.
line from a carboxylic acid, SO2 is one.
PBR3.
PBR3 is another one.
It's all stored up, man. Can't relate.
SO2.
Wait, anyway, I didn't mean that. I didn't mean that. Yeah.
SO2 would create acyl chloride. PBR3 would create acyl bromide. Or you could use PCl5 as well, but that's fine.
I remember Leavens used it.
Yeah, Leavens did use PCl5.
Yeah, I don't know why. She had a thing for it.
Yeah. So let's give practice synthesis film on all of this concepts here.
When you're studying this one, you know 0. Did you start by factoring out things or did you do the stupid first?
This is just going to be 2 steps, 2 synthesis.
I mean, can't be that bad. Wait, no, mine. Wait. Shut up.
2 steps.
Okay, I got it. Take your time.
All the reactions you need to know are on the board right there for the synthesis.
I used to have such a weird shit on my phone.
Oh, no, you
Oh wait, actually, 3 steps synthesis. Yeah, 3 steps. Great.
Wait, I got you. I got you.
So then you want to pair this, do the same thing with the other one. This with
Yeah, I always got 2 steps.
I'm just going
Oh, you only got 2 steps? What'd you put?
Just turn it to carbon and then from that to it.
But remember, it is
Oh
not.
yeah, it is.
Don't you need heat?
Yeah, it is.
Wait,
I thought this was a... Like, if this was anhydride, then there would be 3 steps.
Wait, if it's anhydride, why would it
So
be 3 steps?
let's make it anhydride.
Wait, can't you just do H2O and then SO? Oh, you mean like that? Oh, okay. Now you do H2O, SOCl2, and then the anhydride thing. Huh? H2O?
What did you say? HSO?
No, I said SOCl2.
SOCO2. Oh. Yeah.
Bro was pretty bad. But I got it right. I know I got it right.
This you need to see how it's. What is this? Is this reaction?
Oh, H2O and heat.
H2SO4 and heat.
Yeah.
Wait, I thought you said this as HSO2.
No.
Or something like that.
He's putting bad in you. Like this is like this is bringing some bad reputation. Or PBA.
And then you react again.
With the what? With the what? Say it.
Yeah.
With the yeah.
Yeah.
So you react with the carboxylate.
But if it was an iso halide, then it would be 2 steps, 1 and then 2 yin yang here, which I had originally.
Yeah, Brian is shade on my name.
Hey, when you post this,
Yeah. I sent you it. I'll try to clip that too.
thanks. Oh, so funny.
This is good because I'm gonna reuse this video for my teacher to see again.
When you mean teach again?
Yeah.
In the fall?
No, not here.
Nah, she's by herself.
You got Anakin.
I'm already tutoring physics. Like,
Can you help me with that?
And Justin's here too.
No, we're gonna switch subjects because I'm thinking about tutoring physics next quarter.
I'm gonna do both.
Oh, what physics?
The 7th series.
You know the tutoring's not over summer.
So tutoring's not over summer session 1, potentially summer session 2.
That's so messed up. I need a job. I need money.
Take picture of this. Take picture of this.
Dude, you're cooked.
Yeah. So then draw.
So, you know how we said we want to create the acyl anhydride here, and we use the protein version of that. This is not nucleophilic enough to attack that carbon. So we don't use this as a nucleophile. We gotta use the carboxylate as the nucleophile. The negative charge.
The negative of
Like this, because this is strong enough to attack that now. Before, when it was neutral, it wasn't strong enough to attack it.
He said it's electrical. Why is that again?
Wait, can you say it one more time?
You know how in the other cases, this was able to be neutral to attack that and convert it to an ester, let's say? The reason why this can be neutral with the hydrogen here is because if we compare the lone pair of electrons that would attack the terminal carbon here,
Oh, that's resonance.
this is resonance stabilized, making it more stable, less reactive. Which is why when you see this right here, you gotta
So anytime we want to add an anhydride to something, we gotta deprotonate it?
deprotonate the carboxylic acid to the carboxylate. This is the thing here you use to create the anhydride.
Okay. Yeah, how would you do it then?
He and Shahid had a kid.
If this is on, you would just include that,
Why don't you do it?
the carboxylate. Or you could do this right here.
And Shahid.
You could include
Shahid's the
and then which will lead you to that. Because the point is just deprotonate instead. This way.
Dude, this,
Yeah.
I'm gonna
Yeah.
I'm gonna lose my mind.
Right? It's right there. Wait, just call it protein.
But the other ones here, the
What?
layers of electrons,
Did you say
are not resonance stabilized, which is strong
I'm
enough
moving.
to attack
I'm moving.
that thing in there. No resonance, no resonance. That's why it's less stable. Yeah, it's more stable, less reactive. So we don't want to use that as the last step here.
Right,
We
up
want to
the neck.
include
This is so crazy. Yeah. That's the first one? Or these two? I did both.
Yeah, as well. So the last here include base, or just put that. You can just put neutral carboxylic acid.
Ryan, can you pass me my phone? Scooch. I'm not gonna help you with physics.
And stats. And stats. Forget about stats.
Are you gonna creep my stats?
I really need you to do that. Like, I need to get like. Don't forget. It's when you're free.
You're doing physics this summer, dude.
Okay. So these are all like the interconversion between the carboxylic acids, right? Which is most of the reactions. No, actually no. There's a lot more. You have the gringers now.
Over 7A.
No, stats.
I'm gonna erase this whole board first.
Oh no. I got cooked on my final. So bad. I came into the final with like 3 hours of sleep and I just died.
Girl, look at my notes. Wait, you added more stuff?
Wait, what?
Wait, what? Wait,
What
we
did
just
Bro
take it
did?
again.
He didn't add any more stuff.
Right, so this is the interconversion between the derivatives. Now we're gonna go over like the gradient improvement, like the copper, lithium, RMGBr, and after that we do the reducing agents. Like we went over one already, dibol. There's another one, the bulky one, the Li. LA short, NAB short, and then the other Li. OTB.
Oh, yeah, okay, yeah.
The really bulky one. So this is
Lithium
the
terpetoxide?
Forget about it. And then there's the big ones, HBC, health bars, this
All my classes got canceled.
Really?
Ocam got canceled because Helix was sick.
He's recording a lecture.
Yeah, he is sick, dude. Have you seen him?
No.
He's so fragile.
Wait, Helix is sick again?
Yeah, he's always sick. He always gets sick.
Poor guy.
I think he's like
The rest of the
immunocompromised or something. He gives off that vibe. No, he's a great person. He's like even in lecture, he's like even in lecture, he's just coughing up in the beginning.
Maybe that rock hall was musty.
I mean, I'm not denying that, but do you see professors go like, like 20
No, I don't go.
Ferris doesn't teach about that. Okay, yeah. I'm expecting a good one.
Okay, but I made one last week and you weren't taking it.
What'd you say? You didn't give one.
I made one though, but you weren't taking it.
Yeah, but you still didn't give it.
You didn't ask.
Yeah. You used it for yourself.
Why would I? Yeah, I can take the test.
What is this bullshit? It's so dumb.
So,
Exploitation to the max. I didn't even take it. You didn't even make it for the sole purpose of giving it to me.
I made it for myself.
Exactly,
Dog. What
that's-
I made it for you.
Exactly.
Who do you think you are? Oh, that's on live.
You don't want to be saying that to the person who's going to help you. It'd be a shame if I accidentally gave you some wrong information.
He'll send these things anyway. He always buys stuff.
I mean, go for it. Ain't gonna change what I'm gonna do. Lithium. No, what's Gilman? Who's Gilman? I swear I've never heard that.
This is the name like of this thing here, the copper lithium thing. The
I don't think it's gonna fall. No, it's not even touching the thing. It's not even. It's fine. Exploitation. Put your water. You're just like a fucking tank. You could probably beat someone up with this.
I'm just gonna sit down and know why I added it at one point.
Who?
So for vineyards, you guys just gotta worry about acyl halide and hydride, chromatic acid, ester, and nitrile. You won't see a vineyard with an amide because that's not covered. Yeah.
So like these are the things Grignard's gonna react with.
Yeah.
And it does overreaction?
Yeah, it does overreaction. Right.
I remember because I put that.
You got it.
It was that carboxylate question.
So, let's say we have, let's say this here, MDBR. Like it's not H3O plus. It's gonna be the same exact reaction for all of these.
I agree.
Okay, the weirdest ones are the carboxylic acid and the amide one. For acyl halide, what you're gonna get is 8 and then 1, 2. The R groups of the Grignard attack 2 times to the carbene and carbene.
Can I predict for like, is it for the carboxylic acid is gonna deprotonate?
Yeah, it's gonna deprotonate instead.
And what's the other weird one?
Nitrile.
Nitrile? Nitrile.
Wait, this right here for the carboxylic acid was an acid phase reaction. Because that was a weird one. This started this.
No, I mean, I started this.
I feel like you went into this again
Well, you never know. He could. Like, he was like, oh.
We do what?
Give it to 8 a.m. section.
He's gonna give it to the Thursday section. So us. Because we're taking it last. Yeah, so you'll give it again. He's gonna make it harder for us for sure.
Oh, there's no doubt about that.
But like, do you think he purposely made this one harder? Because like, I know our
He
synthesis.
didn't mean to. I feel like it's
Dude, this synthesis was way harder than no. That Tuesday synthesis was disgusting compared to Wednesday synthesis.
well, I didn't see it.
Wednesday's was a joke in comparison, like actually. So I feel like he already made it harder than
R on the RMGBR. So the RMGBR I used here is this CH2, CH3, which is the CH2, CH3 here. So it could be any R group. It could
What
be
do I do without the
alcohol thing, but in this example here, the R dipoles is 2 carbons long. So this is just the R group here. It doesn't have to be this.
You are?
It could be longer. Yeah.
Why don't you go to
It could be
tutoring?
longer here.
No time.
Oh, coming out of here. Yeah, that would.
Help you in physics?
Yeah. So.
Snacks.
I wouldn't be too stressed about that.
Snacks, flashcards, all of the above.
You can
Oh,
see
no,
my
no,
stash in the past year, dog.
Yeah.
Equal sign for okay,
Oh my
leaving.
goodness.
You better be giving it. If you want that physics tutoring, you got it.
Yeah, I'll do that instead.
But yet leaving.
Wait, what do you mean instead?
Oh yeah, this year.
I'd rather pay you with that.
You're the one
Instead of the flashcard?
No, I'll do that too. Got scared.
I was like, no. Wait, what do you mean by equal?
This circle is equal to the R group. Like, how you do it here. Like all these circles are the R groups. Like this R group here could be different. It doesn't have to be this group here. It could be like a methyl group. It could be isopropyl, terpinol, any R group. Wait, this is like the R group here. The reason
Wait,
why-
so if you're saying if you react MGBR with CN, it forms a carb.
it forms a ketone.
How does it form a ketone? Wait, how does it form a ketone from an MGBR?
Yeah. So the mechanism is really weird. Let me just check that really quick.
Like, is it just MGBR and nothing else?
R MGBR and acid worked out.
I've only heard praise about it.
Guys, me and my needed
Oh, I see what's going on here. Okay. Do you guys want to go over the mechanism of the
Wait, how does it?
Nitrile
Yeah,
to
like how does it
ketone.
form a ketone?
So first it makes an imine, 118B, and then we hydrolyze that imine back to the carbonyl, 118B as well. Mechanism.
So that's what I'm saying. Like, do we not have H2O involved in there or no?
Oh, the one with the negative. Like, oh.
Enamine?
Enamine? There's another one too.
Yeah.
Wait,
No,
so
no,
that's what I'm wondering. Like, because if we just put HMGBR,
HMGBR.
no, not HM, just MGBR. MGBR. Don't even. Right. If we just put MGBR for the nitrile,
That would do nothing.
that does nothing, right?
It has to be RMGBR.
Okay, sure. RMGBR. Fine, whatever. But like, if we just put it for the nitrile,
Yeah.
like, without converting it to an imine, right?
Yes.
What would it do?
It has to go to the imine.
Yeah, so like that's what I'm saying. Like how do you get the oxygen on there? We don't have any oxygen in the things we're adding.
Oh, this right here comes from the H plus workup.
The oxygen comes from H plus.
Water.
Okay, yeah. See,
Water.
that's what I was asking. That's what I was asking.
I was like, wait, what is this discussion?
You're putting so much shade for no reason.
No, you gotta be more clear. You gotta be more
What is
clear.
that? What is that circle? Triple bond R equals to
Oh my gosh. This right here is the R group of the MGBR. It could be any random group, but I just chose this little isotropal group here. It could be different, like for a different reaction. Like for
Oh,
example.
you're saying just that whatever circle equals an R?
Yeah, it's the R for R MGBR, like this. This circle thing is this thing.
Okay.
So you just think of R. Gilman, there's only one thing you need to know about it.
Such a dumb name. Gilman.
Let's say we have. You're gonna stop at one addition?
Oh, shit. Is this also basic?
Yes.
I wrote it.
If I only remember stuff about basic stuff.
You labeled basic things blue?
Yeah. Acidic red, and that makes sense. Purple is nitrogen.
Labeling it based off litmus paper. It's crazy.
What?
That's a pH thing.
Okay, this is R. This is R.
You have to clarify it.
This has to be
No, this
this.
is one that I always don't get. I always get these wrong. It's how you know when to use it, because then they can add either two or
Two times or one time? Like, this tab is two times. Two times. Right? This is the stronger one.
stronger.
This is the weaker one.
Yeah.
They give it like PCC, Jones, NAVH4,
So this
LiH4
reacts once. This.
twice.
Oh.
So is
Except for the nitrile. The nitrile is exception.
so that's the only case. So the nitrile is the only one without overreaction.
Yeah, nitrile is the only one without overreaction, and carboxylic acid is the only one with acid base. So that's why I started these two, the carboxylic acid and nitrile. Everything else, double reaction, happens twice.
I agree.
For acyl halide and hydride, not that, that's acid base. Ester, and then this is like yeah, only once. And you only need to know about that for acyl, the top two reactive anhydride derivatives. Acyl halide.
I was like, who are you raising your eyes for? I was like,
But the strong one is strong enough to attack the weak, less reactive.
That's so funny. I was just like,
Only the strong
Hey, look at
derivatives can
me.
react with the weak organometallic. So, like all of this stuff here,
Yeah, because this is a
Dude,
like.
this is all 118B. Like, guys,
I think some kind of acid.
you should be knowing about this. You should know this. You should know this. You should know physics. You should know.
This is the R.
Only better. That final is bad.
Because I used to do this.
That was a bad final. Sorry.
Wait, so you said whatever we're reacting was weaker?
Just
I mean,
what are you doing?
stronger?
I'm bored,
Like-
so I'm
This
trying to.
strong gradient reagent here
Yeah.
is strong enough to react with the less reactive derivatives like
think,
ester,
This is
nitrile.
okay because I'm
carboxylic
trying the
acid.
first one. This is not.
The
This is
weak
definitely not the
organometallic
most efficient way to do it.
It's not strong
I
enough
did
to
it a
react
different
with.
way.
ester, nitrile, carboxylic acid can only react with the strongest, most reactive derivatives.
What is
The acetaldehyde or the
When you
anhydride.
lose a carbon.
So
Oh,
weak
yeah, yeah, yeah.
can react with strong. Strong can
Starts
react with
with an
strong,
H.
but weak can never react with weak. So if you have a weak reagent
very
and then
common name
another
used
weak
in a lot
reagent, they
of
can't react with each other. One has to be strong enough to react with the weak one.
You know it.
But strong is strong.
I didn't know it until Brian pointed it out.
That makes sense.
Yeah. that pattern's gonna show up again.
Oh,
And what?
Oh no, that's the bonus in B. That's bonus in B.
Don't scare me.
Okay.
No. Bonus in B is showing up right now. Bonus in B.
I got it.
Do we have to care about NABH4 and stuff?
Yes, that's the reducing agents. I'm gonna go over the reducing agents after this. I just finished this. Let's go over reduction now.
You charge your iPad at 10.
Was that 10%?
It's okay.
9%.
Just make it go to 0.
Okay, 60-minute speed run. Reduction, and then HVZ reaction, and then Hoffman rearrangement.
All in 16
All in
minutes?
60 minutes. Okay, I'm just gonna.
See, it would have been quicker. One question per se.
I want to go where? I want to go where?
I'm gonna skip the mechanism because that's a no part thing.
No, not now. Just like, that's the magic. Oh, did you have a bomb?
Dinmans?
Oh, yeah.
Yeah, I bought it in there.
Yeah, you got Dinmans? Oh my god.
Yeah, no, I have
I have a lot.
Yeah.
Yeah, box of difference.
Yeah, where is it? Where is it, huh?
I don't know.
Doesn't have it.
Yeah, because it's in the token. I remember bringing it and it just disappeared for 2 minutes. It's like, who ate it all?
Oh, I ate 4. I chilled the fuck out. Unnecessary shade.
Girl Scout cookies too after that. It's all his
I
Samoas.
had one of his. Chill the fuck out.
One is still too many. Yeah, he only had 2.
No, he had 3.
You ate one.
Yeah.
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 33%.
Okay, stats major.
Yeah, that's why I'm cooking and stuff. Without getting cooked.
Yeah, I need help.
Are you having a harder time with stats over physics? You're doing
Because
open physics
I
and
really
stats?
don't. Because
Oh, okay. I hate it.
that's
Yeah,
why
so
I don't do
when
well.
you have carbonyl,
Like, I have
Do
to
you like your
like,
stats professor? I mean, your physics
base and
professor.
C, right? And there's nothing else. There's not carbonyl right
His name's Gunther?
there. This is gonna be an auto dehydration. Where auto dehydration.
My man.
Chapter 18. Yeah, I started going over this stuff in the last video, so if you watch the video, you should be able to do this video. I also
Sorry.
put timestamp on it. If you go to the video, you go to the outline, the conversation, the reaction video. I tried watching that first and then trying this outline, and then let me know.
Yeah, I have it. I'll do it right now.
That is gonna be PTS.
What?
Send it girl.
OChem?
I don't know what PTS is.
Academic dishonesty.
I don't know. Wait, you see the key? Is that the key?
Are you guys all doing physics or something? I just said. No, but you're gonna be. Wait, didn't you already do something?
This is gonna be
Oh, but you're gonna fail. Okay,
into
sorry.
like this is what
Me too, me too. Girl,
Forget about
Guys,
I have to re-enroll for 7 days. Just read the whole series, girl.
it. Okay.
that's crazy.
Okay.
Yo, no
Charge
rush
your
it. The
thing?
fuck?
Oh, never mind. That shit's gonna
No,
die.
it's
Let's draw all of the things. Do you guys remember all of it? All of the theory of this?
They probably don't.
Yeah, just write it out.
Okay.
Say what loud? No, what is it? I can just, this one? 10? See, I got it wrong. It's not acetone. Well, you're wrong.
Dude, do your TAs actually care?
No,
Really? My TA, dude. Like, for my TA, like, I can just submit it whenever I want and get full points.
wow.
I know.
Who is it?
Zimin.
Wait, it's not.
No, I put acetone when I was grown.
So this is
Apparently it's expensive since acetone is what you're using. It's not.
So even though this one's less,
It's what it's this. Yeah.
so it's only recreation. The way I got the same amount of product, at 0.33, I did not know. You so bad.
Oh yeah, they're all low.
except the A9 and nitro.
Long day. Long
The
day.
carbon of the nitro is this
Busy
carbon.
man.
Same.
I had no classes
Same.
today.
Will only react with the most reactive ones.
Ryan, do you have another show directly after this?
No, I have
You have to prepare.
review
prepare.
session for what it's in the tonight.
Wait, really? No way.
So what an hour and a half I guess. Just gonna get IT or something.
Wait a minute. Wait a minute.
Oh, on him today.
yeah.
Oh, whoa, no. I ain't that rich. Let's calm down, guys.
This is worth more than $5.
Yeah, why don't you pay?
I have no money.
That's such cap. You have snacks, you have Thin Mints.
They're gone.
And I'm going back to SJ tonight. So
Why?
my sister is touring an apartment like after my
SJ?
session. No, here at Davis, and then she wants to go home for the weekend, like tonight after her
Wow,
tours it.
what a good brother.
I know, like I was planning to stay because like I only have a few weeks left.
Yeah, you should have stayed.
Yeah, she has no
Wait,
classes on
Ryan,
Friday.
assert your like
No,
brotherly.
I already told her like last week I'm not going back home. Like she wanted to go home last week, but I told her no.
Why can't your parents drive? No, they're like,
Wait,
oh,
is
I
it possible you
drive
can just
home.
drop your sister off and then you come back?
I could do that, yeah, but I don't.
Cause like, let's be honest.
No, but I
Like,
just chill at home.
Yeah, I'll just chill at home, hang out with my family and dog.
Ryan, no.
Well, we can hang out next week or something. Next week.
Y'all hang out like every day.
No, we don't.
Y'all, you got
I think-
separation.
Wait, chicken tenders from work?
This one's going off already. What are the three derivatives
I'm only
that
friends with
Diamond
smart
can
people.
only react with?
Yeah, I need a bit of a break.
Yeah, that's why I'm
Diamond
not.
can only react with three derivatives.
We blocked your phone number.
Yeah, go for it. You're just gonna hurt yourself.
Yeah, they're not the top ones. Yeah.
Just right.
Wait, what are you
Six
confused?
of the
No reaction.
the three lowest reactive derivatives.
No reaction.
Yeah.
No reaction.
Yeah. Ester amide nitrile. Ester amide nitrile can only react with diamond.
Oh, really?
Yeah.
Beautiful.
Are you guys showing up to tonight's review session? 5:30,
I have
7:30?
class, unfortunately, but I was wondering.
Just skip it.
Probably won't
Skip the class.
I see. Yeah.
Ryan field trip. You should show up. You don't have anything big. No, you don't. What do you have?
Review session for
What do you have?
members.
Who gives a shit about this? You don't need to watch it. Just like don't.
That's the day we got her.
I wish like there was like one session I do B, one session I do C, but I have two sessions B, do B. Yeah, they didn't have to this order.
Wait. What is happening here? Oh, these only react with dieball. Got it.
Yeah, we went over this at the beginning.
Wait,
Yeah, that's the product. That's the most important thing. They break aldehydes.
wait. What about the Ryan?
Huh? Yeah.
Oh, NABH4 obviously doesn't react. Okay, got it.
Choosing to put the books Bible in my phone. Okay.
On our problem, I don't know if Helix gives no reactions, but if you see XO
He
Halide
did
or
it.
He
on
did it.
accident.
Oh, he did? Oh,
He
and
said he'll never do it, but he did.
I mean, technically, it wasn't really. There was still a reaction. He deep throated it. I think it's because you got it wrong, Jacqueline. You feel the urge to say.
Actually,
No, you didn't.
what do you mean?
You got it wrong.
Are you gaslighting?
No, you got it. We got this something wrong.
Yeah.
It's okay. We have a mistake.
So there is a way to make the acyl halide into an aldehyde.
Bro is not sorry. Bro is fuck you. I knew that.
You don't have to see in this form. You can also see in this form right here.
Unless it's loading out. This is also basic.
Yeah.
Oh my god, I did write this.
This little big bookie thing, yeah.
That's crazy, fat shaming.
But luminous.
Bro did not. Dude, that's what Pascal said.
Yeah,
right?
that's what Pascal
I
said,
remember
yeah.
that. Do you remember when he was like barking like a dog? Like he's like.
Oh yeah, he
blah,
was,
blah,
he was,
blah, blah, blah,
yeah.
scenic.
Pascal is funny, but like,
He's such a bad
yeah.
like professor, but he's so funny.
Yeah.
Yeah, it's only that it's still Helix.
This is the back.
Yeah,
Well,
30%. Basic previous
This one
65%
also
of
the top two most reactive, just like the NH4.
and then 55% of both the B,
Yeah.
45% of both the C. I mean, there was 37%.
It's like stuff.
Yeah, L-I-A-L H, and then torque butoxide 3 times attached to the.
She got cooked by.
This is not it. This is not it.
And we know you got cooked.
Wait, isn't the LAH?
We know you got cooked. It's okay. You do better than the average. So yeah. Oh, chill. Okay. Let me guess. 52. Really? Well, that's good though. That's like a, isn't that like an A?
So, to remember these,
I mean, but most
remember
people failing,
that
right?
this is the strongest one that would
Because
react with
if
everything.
45 is a C and 35 is a D.
These two can only react with the top two. Most.
Because 37 must be like a D plus then.
Top two. Diball, bottom 3.
29's a D.
Where these two take aldehydes. Diball and really weird. L-I-L-L. So,
I know someone on the first list got 92.
and if you short.
I mean 94, sorry. 94.
Okay, Pro.
Okay.
Your thing's at
I think I know.
5%. Okay. We only got like 2 more reactions, I think.
Her.
Yeah,
And
250 for
him.
each.
Wait, the high was an 80.
230.
For this one.
So no one got like an uncurved
Yeah, all midterm 1. Hey, Julian.
See my text?
Oh yeah, I saw it, but I didn't have time to respond
got
to it.
a
I
B.
know. Yeah,
I got
you
a
got improved. You improved so much. Like you got like higher than the average.
I know! Like 12 points. I was like, Mom, Ryan did it. Me and Ryan did it.
Yeah, you did it. You put in the work. Like you prepared so early and stuff like that too. That's so good. I know.
Like, literally, I saw it yesterday.
I know. You're so happy. Like what was your reaction to like when you first saw like?
I was in lab. And I was like so distraught. I was like,
And then you checked it.
you know what I love? 86
What are you looking at?
raw.
Like I was just staring at something and then like my eyes started to, you know how like your one eyeball's supposed to be opening and one eye cross-eyed?
Was he the second to go to lecture?
I just looked and then stuff just started getting blurry.
It'd be like
I'm assuming I got this.
same.
Yeah, because you know, different people have different
Is it 180C? For what?
It just takes more time for you to take it in. But I'm so happy, like you got one average, and then like
I need to do it too. Mine was due on Monday.
yeah.
Yours is still open.
Oh, I think actually mine's due next week. Because I have a lab Monday.
I'm looking for you, and I'll send it to you.
Let's go.
Isn't that bad?
No, why? I didn't have to do it this week.
My mom's very happy.
Oh really? That's so good.
My dad started crying on the phone.
Yeah, and then your aunt emailed me too for Gabriel.
Yeah, what about it?
He's
This could have been you.
wait, this is for your classmate now, so
You could be the
we're
one
taking
doing
that for him to get off the waiting list.
His mom
Psych.
is really nice. Embarrassed.
That's so good. That's so good.
There are 3 people here, okay?
Yeah.
You guys
But,
are all in the
he's
same
kind of
clique
like
or
antisocial
whatever.
a little bit. Like,
Like
he's
the
not
Asian
like
girl
me.
clique.
Like him and I are very different.
Oh, like yeah, I see.
He's more of a math guy.
Oh, more of a math guy. Gen Chem? Yeah, that's more Gen Chem than OChem.
Yeah, I think he did really well. They're posting their like when they turn it in, they'll take a screenshot and I'll see if they have like the green ink like check. And I'm like,
Wait, what's cyclic anhydride? Cyclic anhydride. Oh, I remember that. Oh. Ryan, thank you so much.
Yeah, no problem.
Like, without this, I'd probably be cooked.
what are your hours?
For AUTC, Monday 2 to 5 p.m. and then Tuesday 2 to 4
Wait, is
p.m.
that it? Send me that. Wait, this is good because I was gonna not come on Wednesday. And you know what I mean?
Yeah, I don't work here on Yeah.
Wait,
Wait, you're not here on Wednesday?
No, I don't work here on Wednesday.
Oh, bless, because I'm on.
Japan.
Huh?
How would you, if you were to describe the
Yeah.
H1 ride, how would you describe how busy it is?
How busy it is?
The
Not
shifts.
It depends. Each day, each shift varies. Each day varies. And, like, there's no. Like, some days you have so many patients. Some days you don't.
I mean, what's the one you're doing right now?
Right now, I'm doing the neuroscience case 5.
That's the one I want.
Oh, that's what you wanted.
I got dialysis.
Oh, that's still good. You can still learn about all the machines and stuff and all the tools. Like, that's what I did when I was.
But is it boring at all?
It's not boring when you talk to the person.
I like that. I like that. Wait, so you can like talk to the person? Like,
You can talk to the nurses. Don't be annoyed. They're working.
you're chill. Like,
I know. I'm just saying. Like, just don't be like a nag. You can like observe them and just.
oh,
like,
so you can observe them? Is
Yeah.
that what you do?
I observe and then you work on like the desk and just do like inventory stuff and like you talk and interact with patients. It's just,
You do a lot of talking, interacting.
I'd say so. Patients are
Really? But I'm doing it over summer as well. I already did that.
So these ones here are just like reactions. How large is this? Alpha germination. So
this rings a bell.
I like it a lot.
It's kind of acid, like there is a physics.
you could add
What if you do this, and then
It's so funny because like on the finals, everybody was just going like this,
Yeah.
like just like flipping their hand around.
it's annoying because sometimes they make it so that like
Right hand rule.
some of the right hand rules are in.
That's what currents for magnetic.
It's like some of the right hand rules are in awkward positions, and I'm trying to like avoid hand cramps, but I do it.
Or like if it's like this, if like. No, that was me doing the final like going like this. But I think this is too.
Yeah, like at least for this quiz that we had today, outside of like one question that had like some very nasty ratio stuff, that it was straightforward. Like you just applied the rules and then you were more than likely going to get whatever correct.
Okay.
Do you think they're gonna keep the New Testament format after this quiz?
It'd be funny if they did that.
and this A right here
Hopefully not.
has to have no hydrogens on it. Right? That makes the most acidic hydrogen the alkyl. We're gonna
Tutoring physics, either during summer session 2
or amidate
or the fall quarter.
where the nucleophile is
I need a
plug
plug
right there. If we put some kind of electric file
I need
on
to
there,
as well, but it's like you need to like already decide your schedule. And I have no clue what my schedule is
star,
like
that
while
dot,
we're
star,
outside of my
dot,
class.
you'll blast into star and dot. That's
Are you
gonna
planning
be
on doing research?
1, 2.
Yeah, like I'm actively looking to do research right now, and
Amidate
then
appellation. Where we
more than
appellate
likely the
alpha
fall is going to be something that I can't account for by the June 9th
tertiary amide. Like no hydrogens. No hydrogens on
It's gonna be busy fall.
because if there was a hydrogen
You,
in here,
because classes.
then I'll be able to deprotonate H of the N instead of the alpha hydrogen. Right? But if there's no
It's going to
H
be
on N, the most
classes
acidic
here,
hydrogen is the
have
alpha
a
hydrogen.
different part, and then in lab.
You know, like, it's gonna be something like this. Like, if you have a caster,
I have a Pharm Tech license
Same
that
thing.
I am actively neglecting right now.
Oh, nice.
So I need to like.
How does it become a form?
There's no hydrogen
it's
on
like
that
certification.
oxygen there,
It's
so
you
we
take
don't
an exam and you get your
deprotonate that
certificate.
hydrogen.
And what does it like allow you to do?
Hydrogen, right?
And it
Which is
allows
just
you
the nuclear file, because
to
once we
legally work as a
deprotonate it,
pharmacy
negative charge on
technician
that
because it's considered like a
Nuclear
functional
and
job,
start
even though it's
and
like a
dot.
really low-level professional job.
Uh-huh.
But it legally allows you
But what happens if this is a
to
carbonic
fill
acid instead,
medications
instead of an ester?
where
Yeah.
like in order to
If this is
fill
a
out
carbonic acid with an H
you
on the O,
technically aren't
that's the
allowed
most
to do
acidic
that
hydrogen.
unless
That's the
you are
alpha
licensed.
hydrogen. And then that is the hydrogen that gets deprotonated. But since there's no H
Yeah, I
here,
mean,
the most acidic hydrogen is just alpha hydrogen that gets deprotonated to create the hemolyte ion, where this carbon here, the alpha carbon, is a negative charge, which is a new star.
I did it for a while, and then I felt like I disliked it so much.
Cyclic anhydride
Yeah, no, I feel it.
formation is going to be something
I
like
regret.
this,
That's my
where
biggest regret: spending that much money to
there's
get
two
it, and then
things
like
here.
I just like did as much, worked as much I can to like pay it off. And then,
I think for me, I got a really good deal because I also took a course ahead of taking the exam.
we could put this in.
And then the deal that I got was because it was through like my mom's like $150 for an entire pharmacy technician.
We're gonna get this with
That
anhydride.
included like
Anhydride,
paying
that's
off
cyclic.
like the fees
that.
to take the exam itself.
so the whole thing costs $150.
150.
That's kind of crazy.
Yeah.
It would cost like that.
Usually costs
What
that,
associated
but I got a
to
good
do
deal
to
on
one
it,
of the
and
carboxylic
then
acids?
literally
Like,
for
what
my
is this
license
to one
because
of the
you have to also get licensed
Yeah,
by the state.
isochloride.
It
Yeah.
costs more money for me to get my license
Because
than
once we
to
get to this one
actually like get my certificate.
and intramolecular reaction is going to happen. That alpha star will attack that
Yeah.
alpha up there, and
But
minus goes back down.
low-key,
It's up to zero.
pharmacy work
So intramolecular reaction happens way faster than anything else.
Boring?
That's why it only does one, and then
Boring?
intramolecular reaction takes over.
Is it boring?
It's not boring, or at least for me, I find it interesting and love. It's just it's a job that you have to stay
I
on
think on
your
the test,
toes.
it tested
Because it's like
here.
the flow of like
But
prescription
we can also
requests
test this
from
part here, where you
doctors
put SLCO2
never ends. It just keeps going and going and going and going forever. And
with
then
one carboxylic
your
acid,
job is
and then an
to
intramolecular reaction
essentially
happens.
make
Yeah,
sure
this
that the
intramolecular
pharmacy
reaction
can
is
carry
one of the
out
fastest reactions alongside the acid base.
like create them and then give them to
So that's all for Midterm 1 reactions. Yeah. The mechanisms and everything are in note card thing, which I have it here, and I can like send it to you guys if you guys want it as well. Yeah. But I think you guys have your own note cards on that too, so this is fine. Yeah, yeah.
Yes, I'm gonna write my next one.
Uh,
So are we staying here? Or are we leaving?